everybody. Welcome back. I know it's very cold in some parts of India, especially the northern part. So please be careful, please take care. And let us now begin with the remaining of the integration and differentiation. Okay, I purposely mix the two so that whenever you are doing integration, you will remember the differentiation formula also and you'll be very comfortable with it. Okay, yes, good afternoon, Suchiang. Ritu, Dimple, yes, good noon, Dimple, Tanmit, Ananya, Nikita, Soumya Rajan, Pramod, Ayushi, Ashutosh, a very good afternoon to all of you. Yes. So we are talking about integration by parts. So whenever we have integration of two functions, if there is an addition or a subtraction, we perform the integration of the individual functions and then we add or subtract them. But when it is multiplication, what happens is, if I have two functions, one function is u and one function is v, these are functions in x and they are multiplied to each other. And then if I have to integrate this multiplication, then the formula is, it is called as integrating by parts, u, that is the first function, into integration of second minus integration of differentiation of the first function into the integration of the second function. Okay, so that you can see over here, this portion and this portion are the same. Okay, integral v dx is there in the first term also and it is there in the second term also, and plus c is always there for integration. Okay, now the rule is ILATE. Okay, what is the rule? ILATE. I stands for inverse trigonometric function. L stands for logarithmic functions. A stands for algebraic function. T stands for trigonometric functions. And E stands for exponential functions. Okay. Now, since we don't have trigonometry, so what I have to just remember is LAE. So that whenever I have multiplication of two functions, suppose I have e raised to x into x dx, what does this rule say? It says that I should choose the order of the functions. There are two functions here. So I should choose the first function to be logarithmic and the second should be algebraic. Or if I have AE, then the first should be algebraic and then should be exponential. So in this case, instead of doing this, what will I do? Integration of x into e raised to x dx. Okay. So I will just rewrite in LAE order. Okay. Okay. So my first function should be a logarithmic, and the second should be algebraic, or vice versa. Okay, not vice versa, then algebraic and exponential, so that this order is important. Okay, so depending on what I may have logarithmic algebraic, I may have logarithmic exponential, I may have algebraic exponential. Okay, so this is the order I need to follow. Is that clear? So I just have to rewrite. Okay, what I have done, this e raised to x into x dx is equal to integral of x into e raised to x. Okay, why we do that? Because in integration, the power of x increases and so it becomes easier to solve when I am taking the derivative of the first function. So the derivative of x is how much? 1, isn't it? So it becomes easier to solve. So that is all you must know till here, that we will use LAE. Yes, Ankur, Aisha, Aryan, Anushka, Vaishnavi, Tamanna, Manisha, Swati, Richa. Yes. Yes, Anushka, you have written it correct. Now, Ritu, you will get very simple sums on this integration by parts. You will not have big sums, no? That we have in class 12, where you are solving the whole sum. It goes into 1 page, 2 page. Okay, so that will not be the case. Okay. Yes, Kushal. Good afternoon. Okay. So don't worry. All you need to understand is this is an MCQ. The institute also understands that they will give you questions which are solvable in that time. Okay. So don't worry about how and will I be able to solve. Yes, you will be able to solve. You should not like leave this chapter, integration, differentiation, because they will give you simple sums. And then when you see the sum, you say that, oh, I should have just practiced once. I would have been able to do it very well. Okay, we don't want that, right? So because of that, what we are going to do here is we are going to practice those sums. Okay. We will have sums, with 1 step, 2 step, 3 steps, that much only. So let us see. This is my integration x into e raised to x. Now what does my rule say? L, A, E. My first function should be logarithmic. Is there a logarithmic? No. Algebraic and then exponential. Yes, this is AX is an algebraic function. Okay, is an algebraic function. Okay, this E is not visible. And this is your exponential function. Is it clear? So, my order is correct. Now, let me see. Now, what is my U here? U is X. And what is my V here? V is e raised to X. Now, can you tell me how much is du by dx? Can you put it in the chat box? And can you tell me how much is integral v dx, which is equal to integral e raised to x dx? You know the rules? Yes, quickly, very quickly, just put in the chat box. How much is du by dx? What is the derivative of x? Yes, Kushal, I will repeat it. Okay, don't worry. What is the whenever I am integrating multiplication of two functions, the rule says that I should choose using the islet. The order should be chosen this way, that I stands for inverse of trigonometric function. It is written over here. Okay. A stands for logarithmic function, A for algebraic, T for trigonometric, and E for exponential function. So this should be the order. That is, your U should be from here, and then the V should follow afterwards. Okay. But since we don't have trigonometry, we just have to follow the LAE rule. That is logarithmic, algebraic, and exponential. Okay. So that if I have a logarithmic and an algebraic function, I should follow LA. If I have an logarithmic and exponential, then I should follow LE. And if I have an algebraic and an exponential function, it should follow AE. Okay. So that suppose my function is given as e raised to x into x dx, I should write the first function as an algebraic function and the second should be exponential, because I'll be following this rule. Okay. So I will write this to be equal to x into e raised to x dx. Okay. Understood question? Now let us go to here. Yes, so let me see. Yes, Akshata, very good. Du by dx is equal to how much? It is equal to 1. What is integral v dx? It is equal to Nabeen, very good, e raised to x. Yes, Shreya, Nabeen, Liza. Yes, Dimple. Yeah, Richard. Excellent. So this is e raised to x. Okay, so now I have du by dx and I have integral of v dx. Okay, so can I substitute over here? Yes, I can easily substitute over here. So that integral of x e raised to x dx is equal to u is how much? X. Okay, this is my u. X into integral of v dx. Integral of v dx is how much? E raised to x into e raised to x minus integral of du by dx is how much? Du by dx is 1. 1 into integral of v dx. Integral of v dx is e raised to x dx. Okay. Which is equal to x e raised to x minus 1 into e raised to x is e raised to x. Integral of e raised to x I already know is e raised to x minus e raised to x plus c. Okay. So I can write this as equal to e raised to x, x minus 1 in plus c. Okay. Is that clear? So I can have it in either of this form. Yes, Ritu, Kushal, Tanmeet. Yes. Asif, correct. Okay. Has everybody understood? So that if I have multiplication of two functions and I have to find the integration, then it should be done in the order LAE. Here we already have it in order. Algebraic is coming before the exponential, and so I will do it. Then remember, whenever you are solving integration by parts, find du by dx, find integral v dx, so that there is no confusion. You already find it and then just substitute. Okay. Because for this example it was easy, but sometimes you may have signs also. So to be careful, we will be doing it this way. Okay. Now let us see this way. Now sometimes like in the earlier question, it was solved in 2 steps, but sometimes it may need more than 2 steps. So let us see over here how we will solve it. Okay. So there is nothing to be afraid of. So let us do this. Now this is my function, integral x square. Integral x square e raised to 3x. What does my rule say? LAE. So my algebraic is coming before exponential. So my rule has been followed. Okay. So how much is my u? U is equal to x square. Then how much will be my du by dx? It will be 2x. Right. Now how much is my v? V is equal to e raised to 3x. How much is my integral v dx? It will be equal to integral e raised to 3x dx, which is equal to how much? E raised to 3x upon 3. Right? Now I have this. Now I just have to substitute. What does the rule say? What does the formula say? Integral u v dx. When I have multiplication of two functions and I have to find the integration, this is first function, integral of the second function minus integral of derivative of the first function into integral of the second function plus c. Okay. Now here u is how much? U is x square. So x square integral v dx is e raised to 3x upon 3. E raised to 3x upon 3. Minus integral of du by dx is how much? 2x. How much is integral v dx? E raised to 3x upon 3. So e raised to 3x upon 3 plus c. Okay. So integral of x square e raised to 3x dx is equal to x square e raised to 3x upon 3 minus, I take the 2 and 3 out of the integration, minus 2 by 3 integral of x e raised to 3x plus c. Okay. Now, sometimes, you get confused. Why I'm not getting the answer? That is simply because this is to be integrated again by parts. Okay. This is x into e raised to 3x, right? So I have to again integrate by part. Okay. So what I do? I will calculate it here. Okay, I will calculate it separately and then I will substitute. Now let me see what is integral of x e raised to 3x dx. Okay, only this integration I am trying to find out. This is first function x into integration of second function, that is e raised to 3x upon 3 minus derivative of first function. What is derivative of x? Derivative of x is 1 into integration of e raised to 3x. Into e raised to 3x is e raised to 3x upon, okay, not, upon 3 dx, okay, plus is equal to, this is equal to x e raised to 3x upon 3 minus, now this is integral of 1 e raised to 3x upon 3, that is 1 upon 3 integral of e raised to 3x dx. Okay, 1 upon 3 integral e raised to 3x dx, which is equal to x e raised to 3x upon 3. What will be integral of e raised to 3x? It will be e raised to 3x upon 3 minus 1 upon 3 into e raised to 3x upon 3. So this is the integration of this, which I am going to substitute. So that this term I am going to write it as it is, that is x square e raised to 3x upon 3 minus 2 by 3 into the bracket, into this, for this what am I going to write? This x e raised to 3x upon 3 minus, now this 3 into 3 is 9, so minus 1 upon 9 e raised to 3x, okay, plus c. So for this orange, I have written this, okay. The integration of this is this. So from where did I get this? This value is equal to here. X e raised to 3x upon 3 minus 1 upon 3 e raised to 3x upon 3. Okay, clear? So I'll just now open the bracket. So this is equal to x square e raised to 3x upon 3 minus 3 into 3, 9. Okay, so 2x e raised to 3x upon 9. Now this minus and this minus becomes plus. And this 3 into 9 becomes 27. So 2 upon 27 e raised to 3x plus c. Let's see whether we have such an answer. X square e raised to 3x upon 3. These two, no. So upon 3. Okay, first term is x square e raised to 3x upon 3. So c is cancelled. No, c can be an answer. Okay. So B is not an answer, okay, because x square e raised to 3x upon 3. So either of this. Minus 2x e raised to 3x upon 9. Minus 2x e raised to 3x upon 9. So here there 2 is not there. Here 2 is missing. So C is also not the answer. Now plus 2 upon 27 e raised to 3x. So plus 2 upon 27 e raised to 3x plus C. So A is the correct answer. Okay. So I have shown you how this has to be done. Okay. And because I'm telling you very slowly, that's why you feel it is taking such a lot of time. Otherwise, see, integration of e raised to 3x is e raised to 3x upon 3. You can do it verbally. Okay. You don't have to write down every time, right? But only you will do it separately so that it becomes easy initially. Later on, you can, you have to just be careful with the signs. That's all. Okay. Another one that is very famous is log x dx. Okay. Has everybody understood? Just put it in the chat box. Yes, Ritu, understood. Totally clear. Nabin, very good. Yes, Kushal, what do you want here? You want this scrolled up? Okay, everything is available on YouTube. You can watch that, give your feedback. Press the like button for all the efforts that the institute is taking for you. Okay. Now this is log x into dx. This is the unique sum for integration. So we have log x dx. Now, we don't have a formula for integration of log x. So the important step is we write down integral of log x. And then we write down into 1 dx. Okay. So we make this question into a question that can be solved using the U and V rule. Okay. So what is my U? U is log x. What will be my du by dx? I have a formula. Derivative of log x is 1 upon x. Okay. What is my v? V is equal to 1. What is my integral v dx? It will be integral of 1 dx, which is equal to x. Okay. I have my u, I have my v, I have my du by dx, I have my integral v dx. So, integral of u v dx is equal to u integral of v dx minus integral of du by dx into integral of v dx. Okay. So, integral of log x dx is equal to u is how much? Log x. Into v is x. Okay. Into integral v dx is x. Minus integral of du by dx is 1 upon x. And integral of v is how much? Integral of v is x. Okay. And dx. Okay. So this is equal to x log x minus this x will cancel with this x. So integral of 1 dx. How much is integral of 1 dx? It is equal to x. Okay. So minus x plus c. Okay. So this is the answer. Or you can even write it as x log x plus c. Oh, sorry, log x minus 1 minus 1 plus c. Is that clear? Okay. So important step is taking the second function as 1 dx. Taking it as 1. Yes, Rajeshri understood. Shreya, Tanmeet, Punjabi, Asif, Siddharth, Dimple. Yes, excellent. Now we are going to talk about one application that is on page 8.32. That is finding the equation of the curve when the slope is given. Okay. In derivative, what we do is the function is given and then we find the gradient or the slope of the function. Okay. Here we are doing the opposite. The slope is already given to you and you need to find out the equation. Okay. So find the equation of the curve when slope at xy is 9x and which passes through origin. Okay. So this is very important. Why? They will always give you 1 point. Okay. 1 point will be given to find value of c. Value of c. That is the constant. Okay. Until unless we have that, we can't find the perfect equation of the function. Okay. So find the equation of the curve whose slope at xy. So dy by dx is given to me as 9x. Okay. Dy by dx is given to me as 9x. I write this as dy is equal to 9x dx. I write this as dy is equal to. So I take this dx onto this side. Now integrating on both sides, I have integral of dy is equal to integral of 9x dx. Okay. Integral of dy means what? It is as good as integral of 1 dy. Okay. So what is integral of 1? It is y. Okay. Because this is dy. Had it been integral of 1 dx, it will be equal to x. But here it is integral of dy, so it is y. This is equal to 9 integral x dx. What is the formula I'm going to use? Integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1. So how much will this be? This will be equal to 9x square upon 2. Y is equal to 9x square upon 2. Okay. Now, okay, this is important. This is important. Now the step 3 is substitute value of point given. Now here directly I can't see any point. Okay. Directly I can't see any point, but this is very important. It passes through the origin. That is this line that I'm trying to draw. This line that I'm trying to draw is passing through the origin. Okay. Okay, this is my line. This is passing through the origin. No, but the x square. No? That is, this should be the point through which it passes. It will not be a straight line because it's x square. Okay. So it will be a curve. So what I mean by passing through the origin is passing through the point 0, 0. Okay. So substituting value of the point which is equal to 0, 0 as equation is passing through origin. Not equation, function. Okay, so substitute value of point 0, 0. So now what will it be? So it will now be y 0. So that means x is equal to 0, y is equal to 0. Okay. So 0 is equal to 9 into 0 upon 2 plus c, which implies what? C is equal to 0, which implies c is equal to 0. Therefore, my equation is y is equal to 9x square upon 2. So my equation becomes 2y is equal to 9x square is the answer. Okay. Is that clear? So first step is write dy and on left hand side and dx on the right hand side. Second step, integrate the on both the sides. Third step is substitute the value of one of the points given from which you can find the value of c. Yes, clear? Everyone? Yes, very good. 9x square is equal to y. Dimple, Tanmeet. So third step is what? We substitute the value of a point that will be given to you. In this case, the point is given to be origin. At origin, value of x is how much? It is 0. What is the value of y? It is 0. So in the equation, in this equation, I will substitute value of x as 0, y is 0. This is giving me the value of c is 0. Okay, this is important. Once I know the value of c, I just have to substitute and I get the answer. Okay. Okay, now let us go to definite integrals. In definite integrals, what happens is that they've already told you the range within which the my x is going to lie. Okay, so in this case, I don't have to find the value of c. When I'm integrating it, that will take care of the value of c. Okay, so that is definite integral. So integral of a to b of fx. So what is a? A is the lower limit. And what is b? B is the upper limit of x. This is, in this case, it will be of t. Okay. Now, what are the different properties? Is that integral of a to b fx is the same as is minus of integral of b to a of fx. So that if I go from a to b, and I get a certain value of the integral, but if I go from b to a, the value will remain the same, but the direction is going to change. So that plus becomes minus. Okay. Then I can even add this a third number. So I can find the integration from a to c and then from c to b. Okay. So for example, I have this as okay, suppose this is 1 and this is 5. Then this 1 will be my A and this 5 will be my B. Then I can choose a point C. Okay, I can choose a point C so that when I'm integrating, I can find the integration from A to C and then from C to B. It is the same as finding the integration between A to B. Okay, it is the same as. Provided obviously that C is lying between A and B. Okay. Then this is also one property they can ask for theory. Integral from 0 to A of fx is equal to integral of 0 to A of f of a minus x. So that if I have f of x, then it is equal to f of 3 minus x also. Okay. So it is going to be the same value. But provided what? The limits are 0 to a. Okay. And suppose I go from minus a to plus a. Here what was happening is I'm going from a to b. Okay. But here if I'm going from minus a to plus a, so that this is my 0, this is my a, and this is my minus a. Then it says that integration from here to here will be equal to integration from here to here. Okay. The integration from here to here, minus a to 0, will be the same as integration from 0 to a. And so we write that from minus a to plus a is equal to 2 times integral 0 to a of fx dx. Okay. So let us see this. Okay. Here, what is happening? My function is x raised to 5 and it is going from 0 to 3. So, okay, I've already written the answer. Okay. Here. Now, this is my simple integration. What is the integration formula? X raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Okay. But here it is definite integral. So that on the number line, this is going to be 0, 0. And what is the value of x? From 0 to 2. So suppose this is 1 and this is 2. So my integration is only going to be between this limit. Okay, this limit. So this is equal to how much? This is equal to x raised to 6 upon 6 limit going from 0 to 2. So what I will do, I will first substitute the higher limit and then from that I subtract the lower limit. So this is equal to x is 2. So 2 raised to 6 upon 6 minus 0 raised to 6 upon 6. 2 raised to 6 is how much? 2 raised to 6 is 64. 2, 4, 8, 16, 32, 64 upon 6. 0 raised to 6 is 0. Okay. Now 2, 3s are 2, 3 and 2s are. So answer is 32 upon 4 is equal to integration from 0 to t to x raised to 5 dx. Okay. So what does this give you? It gives you the area under the curve x raised to 5 when integrated. Okay, so when I'm finding this, what I'm doing to find the area under the curve, I'm using this. And what is the limit from x going from 0 to 2? Okay. It is equal to 32 upon 3, sir, not 4. It is 32 upon 3. Okay, now let us take the next sum. Integral 1 to 2 x square minus 5x plus 2. Now this is equal to, using the addition and subtraction rule, this is equal to 1 to 2 x square dx minus 5 integral 1 to 2 x dx plus 2 integral 1 dx 1 to 2. Okay. So this is equal to how much? Integral of x square is x cube upon 3 going from 1 to 2 minus 5 x square upon 2 going from 1 to 2 plus 2 into x going from 1 to 2. So what I will do, I will write this. How much is this? 2 raised to 3 is 8. 8 upon 3 minus, when I substitute 1 over here, 1 cube is 1. 1 upon 3 is 1 by 3. Okay. Then minus 5. Okay. X square, 2 square is 4. 4 upon 2 minus 1 upon 2 plus 2 into 2 minus 1. Okay. Now, if I solve this, how much do I get? 8 minus 1, that is equal to 7 upon 3 minus 3 upon 2, 15 upon 2 plus 2. So this is equal to upon 6, 7 2s are 14 minus 3s are 45, 6 are plus 12. Okay. So how much is this? 14 plus 12 minus 45, which is equal to minus 90. Minus 19 upon 6. Okay. Okay. Some students prefer it this way. Others, you can directly do it also. Okay. Now here I will first find the integration and then find the limit. Okay. Now what is the integration of x square? It is x cube upon 3 minus integration of 5x will be equal to 5x square upon 2. What is integration of 2? It is 2x. What are the limits? 1 to 2. Okay. Now I directly substitute. 2 cube is 8 upon 3 minus 2 square is 4, that is 20 upon 2 plus 2 into 2 is 4. Okay. This is for value when I put 2 minus what is the value? 1 upon 3. 1 cube upon 3 is 1 upon 3 minus 5 upon 2 because 1 cube x square is 1 plus 2. Okay. Now how much is this? This is 16 minus 16 plus 24 minus 2 minus 15 plus 6 2s are 24. 6 2s are 12, sorry. So how much is this? Upon 6. Okay, this whole thing is upon 6. So 60 with a minus sign plus 16 plus 24 is minus 20. Minus 20 minus of how much? 15 to minus 15 plus 12, which is equal to minus 1. Minus 1 into minus 1 becomes plus 1 upon 16, which is equal to minus 19 upon 6. See, so both the answers are coming the same. Only here is I have taken individual factors and I have found the integration and then put in the limits. Then same thing as doing this. Okay. Once I am comfortable, I can directly do this also. But initially, I would prefer you to do with the left hand side method. Okay. Any doubt you have till here? Crystal clear? Very good. Yes, Rabish, doesn't matter. You okay? You can see, you follow from here, and whatever you have missed due to network issues, you can see it on the YouTube. Okay, no problem. Yes, good, Shreya. It's clear. Nikita, Ankur, Krishna. Okay. So integration is reverse of differentiation. So what are the formula? D by dx of x raised to n is equal to nx, n x raised to n minus 1. Okay, then d by dx of e raised to x is e raised to x, d by dx of a raised to x is a raised to x log a, d by dx is constant is equal to 0, d by dx of e raised to ax is a e raised to ax. Okay, and d by dx of log x is 1 upon x. So when I find the integration, I find it that integration of x raised to n is x raised to n plus 1 upon n plus 1. Integration of 1 dx is x. Integration of e raised to x is e raised to x plus c. Okay. Integral of e raised to ax dx is e raised to ax upon a. And integration of 1 upon x dx is equal to log x plus c. Integration of a raised to x dx is equal to a raised to x upon log a plus c. Okay, so we have done all these sums. Okay, these are other formula that are present in the book. Okay, you can just go through those formula so that you must know these formula. You may get a direct question on the formula itself, or simply even when you get a question, it becomes very easy once you know the formula. So dx upon x square minus a square is equal to 1 upon twice a log of x minus a upon x plus a plus c. Okay, then dx of, so that what is the type of, okay, so you may get integral of 1 upon x square minus 9 dx. Okay, so what does this mean? This is of the form x square minus 3 square. Okay, 9 you have to write. Okay, this is the most important set. So what is my a? A is equal to 3. Okay, so once I know this, so this is written as integral 1 upon x square minus 3 square and dx is equal to 1 upon twice a. What is my a? A is 3. That is the most important thing that you have to remember. So this will be 1 upon 2 into 3 log of x minus a. X minus 3 upon x plus 3 plus c. So this is equal to 1 upon 6 log of x minus 3 upon x plus 3 plus c. Okay. Similarly, you may have it the other way around. Okay. You may have the question as integral of dx upon 9 minus x square. So in this case, what you will do, right? This is integral of dx upon 3 square minus x square. What will be my value of a? A will be 3. So when I have this, what is it is 1 upon twice a log a minus x upon a plus x upon a minus x. Okay, so a you have to find the value. Then you may even have like this dx upon under root of x square plus a square. So here you may have, suppose a question, dx upon square root of, you may have x square plus 25. So this should be written as integral of dx upon square root of x square plus, instead of 25, what should I write? 5 square, right? So what is my a? A is equal to 5 in this case. So what will be this answer? It will be equal to log of modulus of x plus square root of x square plus 25 plus c. Okay. So you can have this type of simple questions. For that you need to know the formula. Then you may have integral of x square plus a square. So you may have a question integral of, find integral of x square plus 16, okay, dx. In this case, you will be writing this formula, x upon 2 integral square root of x square plus a square upon 2 log of x plus x square plus a square with the, in the under root sign. Okay, integration of parts also I will just revise. So whenever I have integration of two functions, then integration of multiplication of two functions, then I will choose u and v according to the rule eyelet. But for us, only LA is important because we are not dealing in trigonometry. So logarithmic, then algebraic, and then exponential. And what does the integral of uv say? It says first function into integration of second function minus integration of derivative of first function into integration of second function and dx. Okay, so this is the formula. Then we have taken these 3 sums. Okay, there is this rule that integral of constant into the function is, we take the constant outside the integral and it gives you integral of fx dx. Okay, if I have addition subtraction of two functions and I have to find the integration, it is equal to integration of the first function plus minus integration of the second function. Okay, this can be asked for a theory question, that integral of e raised to x fx plus f dash x. Suppose I have an exponential function which is multiplied by the function plus its derivative, then it is equal to e raised to x fx. Okay. Suppose you have integral of derivative upon the function. Okay. Suppose I have integral of x square upon x cube. Okay. Then in dx. So what do I have? This is equal to log of fx. Okay, so it is equal to log of fx. Obviously, you will have to make adjustments for the power, that is 2 and 3, which is going to come out. But other than that, this is equal to log of fx. Okay. So these are mostly you require for the theoretical part. Okay, there is one sum on page 8.34 which I would like to take. Okay, so if you could open your study material, page 8.34. Here this property which we already know, but this is an important property, that is integral of fx dx, integral of 0 to a f of a minus x. Okay. So integral of 0 to a fx dx is equal to integral 0 to a f of a minus x. Okay. So what happens here is, this is the example I am talking about. Okay. I have 0 to 2 x square plus 2 minus x square whole square. Okay, so here what it says is that if I, instead of x, I write a minus x. Okay, it is going to be same as this function. Okay, so let me try writing, instead of x, I will write a minus x. What is my a here? A is 2. Okay, see, this is 2 and this is 2. Okay, so I'm going to write it as this is equal to integral 0 to 2. Instead of x, what will I write? 2 minus x. 2 minus x whole square dx upon, instead of x, I will write 2 minus x whole square plus 2 minus, instead of x, I will write 2 minus x, minus 2 plus x whole square. Instead of this x, I am writing 2 minus x. So minus into plus will be minus, minus into minus will be plus. So this plus sign is very important. Okay. So when I simplify this, this is equal to integral 0 to 2 minus x whole square upon, this is 2 minus x whole square plus 2 minus 2 will get cancelled. I have plus x square. Okay, dx. Okay. So what happens is, this is equal to this. Okay. So if I add them up, so what is happening here is we are adding them up. Here they have written it is 2i. Okay, this is 2i and it is not 221. This is 2i. How did I get the 2i? This they have not explained. So this is, I use this one. I add this and I add this. Okay. So adding 1 and 2, this I am writing as equal to I. Okay, this I am writing as equal to I. So I plus I on the left hand side, this plus this is equal to integral 0 to 2 x square dx upon x square plus 2 minus x whole square plus integral 0 to 2. I'm going to write the second function, 2 minus x whole square upon 2 minus x whole square plus x square into dx. So how much is this? I plus I, this becomes equal to 2i. Now what will this be equal to? This is equal to integral of 0 to 2. Denominator is same, x square plus 2 minus x whole square. This is also x square plus 2 minus x whole square. X square plus 2 minus x whole square. What is there in the numerator? X square. What is there in the numerator here? 2 minus x square. 2 minus x square dx. Okay. Now can you see in the numerator also have x square plus 2 minus x square? 2 minus x the whole square. In the denominator also I have x square plus 2 minus x the whole square. So what I can do, I can simply cancel this with this. What is left is 1. Okay. This is equal to integral of 0 to 2, 1 dx. What is the integration of 1? It is x. What is the limit? 0 to 2. So I will substitute, which is equal to 2 minus 0, which is the answer is 2. 2 minus 0 is 2. Okay, so what is this value? This value is equal to 2. Okay, this is more for your understanding so that you know how to do such type of things. So that when I cannot have a direct answer, I will use the property f of x is equal to f of a minus x, and I am able to solve this. Kushal, last in the blue part, the earlier sum. Yes. Okay. Yes, Kushal. Right. Now you got the answer. Okay. So this is one sum I wanted to take. We know break ले सकते हैं. Welcome back. So let us now go to some sums on differentiation. Okay. So now here the gradient of the curve. Gradient of the curve means the slope of the curve. Okay. The word gradient means what? It means slope of the curve y is equal to this at x is equal to 0 is. Okay. So whenever you have this sums, they will give you some point so that you will be able to find the value of the question. Okay, so here they want you to find the slope. So they want you to find it at what point? They want to find you to find it at x is equal to 0. Okay, now I have what is my equation of the curve? The equation of the curve is y is equal to 2x cube minus 3x square minus 12x plus 8. Okay, this is the equation of my curve and I want to find the gradient. Okay, remember in geometry we have studied. Okay, let me take this. Suppose this is my line. It not come out a straight line. Okay, so what will be the slope? Slope will be small change of y upon small change of x. So this is dy. This is the small change in y upon what is this? This is the small change in x. This using this I can find this the slope of the curve. Okay. So dy by dx, I find dy by dx. What is the derivative of x cube? It is 3x square. Derivative of x cube is 3x square. Can you see now? We don't have to write down d of x cube upon dx. Okay, we just looking at the function because I know the formula d of x raised to n. Derivative of x raised to n is n x raised to n minus 1. So x cube will be 3x square minus 3. X square will be 2x minus 12. Derivative of x will be 1. Derivative of constant 8 will be 0. Derivative of a constant is always 0. So slope or gradient at x is equal to 0, I have to find out. Okay. So this is equal to 6, 2 into 3, 6, x square minus 6x minus 12 at x is equal to 0. What does this mean is I have to put the value of x is equal to how much? Equal to 0. So this is 0 minus 12. So answer is minus 12. So A will be the correct answer. Okay. Understood? Yes, Aditya Darshan, using properties, solving this becomes very easy. Okay. Yeah. Yes, Siddharth, minus 12, Dimple, Kushal, correct. Okay. Now the second sum also. Can we do that? Can we do that? Slope or gradient is equal to dy by dx, which is equal to 2. What is this? X cube is 3x square minus 5. X square is 2x minus 3. Okay. The derivative of 3 is 0. Okay. Derivative of 3 is 0. Okay. So this is equal to 6x square minus 10x. Oh, no, it is 3. Sorry. It is 3x. Okay. Derivative of 3x is 3 minus 3. Okay. So slope at x is equal to 0 is equal to 6 into 0 minus 10 into 0 minus 3. So answer is minus 3. So B will be the correct answer. Okay. Can you see how easy it becomes? You can see that? The only thing you need to know is gradient is what? It is the slope. And what is the slope? It is dy by dx. Simple. Okay. Right? Everybody is with me? Okay, the derivative of y is equal to square root of x plus 1. All these questions are from exercise 8A. Okay. Now, you can either do this directly also, but if you're not comfortable with that, because here it is okay, here it is x plus 1. What if it is 3x plus 1? What if happens inside? Okay. So, the method that I use is let x plus 1 be equal to t. Taking derivative or taking differentiation on both sides, what will be the derivative of x plus 1? It will be dx plus 0 is equal to dt. Okay, so how much is dx? Dx is equal to dt. Okay, so y will become how much? Y will be equal to square root of t. But what have they asked me? They have asked me to find derivative of y with respect to x. Okay, so dy by dx is equal to dy by dt into dt by dx. Okay, this is what I am using. So this is equal to dy by dx is equal to dy by dt. So this is equal to d by dt of square root of t into dt by dx. How much will be dt by dx? Dt by dx will be equal to 1. Okay. If I divide both sides by dx, what will I get? It will be equal to 1 into 1. So, derivative of square root of t is how much? This is equal to t raised to 1 half minus 1 into 1 half. So, this is how much? N was how much? 1 half. So, this derivative will be 1 half. So, this is 1 half t raised to minus half, which is equal to 1 upon 2 square root of t. T raised to minus half is 1 upon t raised to half. What is t raised to half? It is square root. So, answer dy by dx will be equal to 1 upon 2 square root of x plus 1. I resubstitute for t. So, I get 1 upon 2 square root of this. Okay, so C will be the correct answer. In this case, you could have easily done it directly also. Why I'm showing you? Because here it is only x, so it was possible. Other than that, you have to take into account what is the coefficient of x. So, is it 5x minus 3x? Okay, so that also has to be considered. Otherwise, this is directly dy by dx is equal to x plus 1 raised to 1 half minus 1, and what is n? N is 1 by 2, which is equal to 1 by 2 x plus 1 raised to minus half, which is equal to how much? 1 upon 2 square root of x plus 1 plus c. Okay? Not c. We are doing derivatives. Okay? Is that clear? I've shown you both the methods so that sometimes you get some coefficient with x and then you don't remember. So even for the simple sum, I've used the method so that you will be able to do it. Yes? Clear? Yes, Nabeen, it is the most interesting questions you've seen. Very good, very good. Yes. Siddharth, Kushal. Nabeen, step after y root x root t. Okay. What happens is then you have to resubstitute y square root of t. Then this step means what? Because the question says I have to differentiate y with respect to x, right? So what I do, I use the chain rule that I first differentiate y with respect to t, then I differentiate the t with respect to x, and I get dy by dx. Okay, that is what we have used. Let us go to the next sum. Here it will be all the more clear. Okay. I have fx e raised to ax plus bx plus c, and they are asking you to find f dash x. Okay. So let t be equal to ax square plus bx plus c. Then dt by dx is equal to, when I am differentiating ax square, it will be 2ax. Differentiating bx will be b plus 0. Okay, dt by dx is equal to 2ax plus b. Okay, what do I know? That dy by dx will be written as dy by dt into dt by dx. Okay, now I have my, what will be my f? What will be the function? Function will be e raised to t. This is ax square plus bx plus c. It will be e raised to t. So y is becoming e raised to t. Now dy by dt will be equal to how much? It will be d by dt of e raised to t. I already know what is the derivative of e raised to t. It is e raised to t. Okay. So this becomes how much? dy by dt is how much? E raised to t. So this is equal to e raised to t. How much is dt by dx? It is equal to 2ax plus b. That is equal to 2ax plus b. Resubstituting for t, I get f dash x to be equal to 2ax plus b into e raised to ax square plus bx plus c. Okay, so which one will be the answer? B will be the correct answer. Okay, this is here. This is the third option. Dimple, good. You did the second time. Kushal, which screenshot do you want? Earlier one or this one? Yes, Vadekar. Today is the first time you are answering the whole day. Huh? Answer more. Manjunath. Manjunath, these are the live coaching classes for May 23. Okay. Yes, taken. Kushal, good. Is that clear? Now, for this question, you can see there are two functions. Fx is x square plus 1 upon x square minus 1. So, when I have the function u upon v form or f upon g form, then you will be using this. Okay. So, if I have d by dx of the form u upon v, I'm purposely not using f because here see, this is also f in the formula. Here also it is f. We don't want that confusion. Okay, if it is d by dx of u upon v, u is a function in the numerator and v in the denominator, then we have denominator function square in the denominator function into derivative of the first function minus second function minus first function into derivative of the second function. Okay, so derivative of two functions in the division mode will be given by in the denominator it is second function whole square, and in the numerator it is second function into derivative of first minus first function into derivative of second. Okay, so in this case, what is my u? U is equal to x square plus 1. What will be my du by dx? It will be equal to 2x. What is my v? V is equal to x square minus 1. What is my dv by dx? Which is also equal to 2x. Okay, du by dx is also 2x, dv by dx is also 2x. I have my u, I have my v, I have my u dash, and I have my v dash. Okay, so substituting, so d by dx of x square plus 1 upon x square minus 1 is equal to denominator x square minus 1. Let me write it properly. X square minus 1 the whole square. Okay, don't forget to square the denominator. Then x square minus 1 into du by dx. It is 2x minus first function. First function is x square plus 1. X square plus 1 into derivative of the second function, which is also equal to 2x. In this question, it has happened. Both are 2x. This is equal to upon x square minus 1 the whole square. I expand the bracket. This becomes 2x cube minus 2x minus 2x into x square, 2x cube. 2x into plus x plus 1 is 2x, with the minus sign it becomes minus 2x. So this 2x cube will cancel with this 2x cube, but this is minus 2x, so please don't cancel it. Okay, this is minus 2x, answer is minus 4x upon x square minus 1 the whole square. 4x, x square minus 1 the whole square. So B will be the, no, not B. Sorry. A will be the correct answer. Minus 4. So minus 4 is, A is the correct answer. Understood everybody? Okay, just put it in the chat box whether you have understood. Resubstitution in the earlier sum, Kushal? Yes, Dimple, correct. Yes, Vadekar. Yes, Kushal. Resubstitution here. Okay. See, whatever the value, whatever you have t, okay, wherever you see t in the final answer, see, you see this t over here. Instead of this t, I will write t to be equal to how much? What is my value of t? T is ax square plus bx plus c. Every sum you will take different values for t. In this case, it is 2x ax square plus bx plus c. So instead of writing e raised to t, I will write it as e raised to ax square plus bx plus c. Clear? Got it? Yes. Okay. Okay, now what is happening here is, let me see whether I have that sum. Now I have to also, just let me, okay. I want to take a parametric equations. Okay, you will have simple sums on parametric. See why? That is why I have taken the chain rule first, and now you will appreciate the parametric equation. Now what happens is in the sums we did up till now, for ease of calculation, I have taken the one of the functions of x in terms of t. But what happens if both y and x are expressed in terms of t, and but you want to find the differentiation of y with respect to x? We don't want it with respect to t, we want it with respect to x. When both the variables x and y are expressed in terms of a third parameter, it may be t, it may be p, it may be a, okay? If two functions or two variables are expressed in terms of another in terms of a third variable, then we say the equations are parametric equations. Okay, so for example here, this is the question. Can you see this? X is equal to at cube and y is equal to a upon t cube. Okay, so if I find dx by dt, how much will this be? This will be 3a t square. 3a t square. How much will be dt by dx? I just have to find the reciprocal. This will be 1 upon 3a t square. Now what about here? Y is a upon t cube. How much is dy by dt? Dy by dt, this is equal to a t raised to minus 3. So this is equal to minus 3a t raised to minus 3 plus 1. Okay, t raised to minus 3 minus 1 d by dx of x raised to n is equal to n x raised to n minus 1. What is n here? Minus 3. Minus 3 minus 1. So this becomes minus 4. Okay. Now I have dy by dt as minus 3a t raised to minus 4. I have dt by dx is equal to 1 upon 3a t square. Okay. So I have dy by dx is equal to dy by dt into dt by dx. Okay. I can cancel this dt by dt and I can get dy by dx. But because the two functions are given in terms of t, so what I have here is, I have to just write down how much is dy by dx. This is equal to minus 3a t raised to 4 into dt by dx, and that is why we found dx by dt, and so I wrote it the reciprocal dt by dx. This is equal to 1 upon 3a t square is equal to 1 upon 3a t square. Color. So I can see this 3 will get cancelled, this a will get cancelled, and the t will also get cancelled. Okay. So how much do I get? What is left? Minus t square. Where did it go? Oh, this is -4. Okay, so this will not get cancelled. This is t raised to -4. Okay, -3a t raised to -4 into 1/3a t square. So this will remain t square. 3 will get cancelled, a will get cancelled. So how much do I have? This is equal to minus t raised to -4 upon t square. This -4 I can bring down. This is equal to -1 upon t raised to 6 will be the answer. So what is the differentiation of the parametric function? What a parametric function? When two variables are expressed in terms of a third variable, and then we call the equations that are involved are called as the parametric equation. Okay, so here this was -4. So -4 and this is t raised to 2, and therefore they did not get cancelled. So this is the answer. Okay, I will just write down dy by dx is equal to dy by dt into dt by dx. How much is dy by dx? -3 a raised to, this is equal to -3 a t raised to -4 into dt by dx is 1 upon 3 a t square. So 3 gets cancelled, a gets cancelled, and I'm left with how much? I'm left with this minus sign, and I'm left with this -4 t raised to -4, and I'm left with t square. Okay. So this is equal to -3 t raised to 6 -1 t raised to 6. Okay. The 3 has got cancelled. Yes, Pramod understood. Asif. Akshata, how do you know that this is place where you have to take the actual and where it is? If you have a direct formula, use that formula. Okay, then you get the answer. Then in case of integration, when they want, they will give you the value at x is equal to value for x, and or they will give you a pair of value x, y, and then you will have to find. Okay, so in differentiation and integration, if looking at the sum, you can directly see that you can get the answer because of the so many formula, and if you can apply those formula, you'll get the direct answer. But where it is not possible, or it becomes simpler, okay, simpler to put x is equal to something in t, and then you solve it, it becomes easier, then do it. Okay. Okay, you're not able to see the screen? Okay, just a minute. Okay, this thing you're not able to see. Okay. Let me take it over there. So what is the question? The question is x is at cube and a upon t cube. Okay. Okay. Not able to see over there. Let me just do it over here. X is equal to at cube, y is equal to a upon t cube. Okay, when these are the two parametric equations that are given to you, then I find out dx by dt. Dx by dt is 3a t square. So dt by dx is equal to 1 upon 3a t square. Okay. Now let us see y. Y is dy by dt, which is equal to a into minus 3, because this is equal to what? A t raised to minus 3 into t raised to minus 3 minus 1. So that becomes minus 4. So dy by dt is equal to minus 3a t raised to minus 4. Then I have dy by dx to be equal to dy by dt into dt by dx. dy by dx is how much? dy by dt is how much? Minus 3 minus 3a t raised to minus 4 into dt by dx is how much? 1 upon 3a t square minus 1 up into 1 upon 3a t square. So my 3 will cancel with this 3. My a will cancel with this a. And what will I be left with? In the numerator, I have minus t raised to 4 upon t square. Now I cannot cancel this because this is minus t raised to minus 4 upon t square. Now I know a raised to minus 1 can be written as 1 upon a. So instead of this, I am writing minus 1 upon t square was already there into t raised to 4. Okay. Minus 4 becomes plus 4. So this is equal to minus 1 upon t raised to 6, which is equal to minus t raised to minus 6. Okay. So this is the way you have to answer this. Akshata, you can see. Asif, you can see now. Okay, I'm going to take a question on page 8.10. Y is equal to x raised to x. This is of the type function raised to function form. Okay. So whenever you have such complicated thing, it is easier by taking logs on both sides. Okay. Okay, you've studied in the first chapter. This is equal to log y is equal to log of x raised to x. Log y is equal to log of x raised to y. Now you remember the formula. Log of a raised to m is equal to m log a. Okay, so we are going to use this over here. Then this becomes, this is equal to x log x is equal to log y. Okay, derivative of log x is how much? 1 upon x. So differentiating on both sides, I have 1 upon y dy by dx to be equal to x log x. So I have derivative of uv d by dx of uv is equal to u into derivative of v plus v into derivative of u. Okay. So this becomes x log x. X into derivative of log x is 1 upon x plus log x into derivative log x into derivative of x is how much? 1. Log x into derivative of x is how much? 1. So this also gets cancelled. So I have 1 plus log x. Okay, I have 1 plus log x. So I have 1 upon y dy by dx to be equal to 1 plus log x. So I want to find dy by dx, right? Dy by dx is equal to y. Cross multiply. I take this y to this side. Okay, so y into 1 plus log x. What is now value of y? Y is x raised to x. Okay, it's given to me. So this is equal to x raised to x 1 plus log x. Okay. Have you understood this sum? Oh, Ayush, thank you so much. Your comment has made my day. Ayush has written, better than 1,000 days of diligent study is one day with great study with you, ma'am. Thank you, ma'am, for explaining deep and easy way. Thank you. Yes, Dimple, crystal clear. Akshata. Yeah, thank you, Ayush. Thank you so much. Okay. So I hope you've understood that whenever you have a little complicated sums like this, function raised to a function, then what do? Is I will take logs. Okay. Remember that you don't have to do this. Okay. Suppose my function is, maybe let me take this. Suppose it is x raised to 5. Then I will use the simple formula. Okay. I don't need to. Because here the number is it's only a number, but here what is happening is I have raised to x, so that is why I need to do it. Okay, hope this is clear. Then I also want to take this. Umar, yes, clear. Tanmeet, yes, clear. Very good. Now there's one more sum that I want to take. If, okay, this is the sum. If y is equal to square root of 1 minus x upon 1 plus x, show that. Okay, so you will not get show that. They will ask you what is the value of 1 minus x square dy by dx plus y. Okay, they may ask you this. Then they will ask you to find this value. Okay, so here also there are two ways of doing it. Either you square it and solve it. Then what will happen? Y square is equal to 1 minus x upon 1 plus x. You can do that. Or you can take logs. Okay, I will show you both the methods. Take whichever method you find is easy. Now first I am taking logs. Okay. Taking logs on both sides. So I have log y to be equal to log of 1 minus x upon 1 plus x raised to half. Okay, because this is the square root. So this is most important, raised to half. Now which is equal to, you know that log of a raised to m is equal to m log A. Did not come out well. M log A. Okay. And you also know that log of M upon N is equal to what? Log M minus log N. Isn't it true? Okay. So, using these two, I'm going to simplify this. This is equal to 1/2 log of 1 minus x upon 1 plus x, which is equal to 1/2. Using the second, this is equal to log of 1 minus x minus 1/2 log of 1 plus x, right, is log y. Now differentiating on both sides. Differentiating on both sides. What is the derivative of log y? 1 upon y dy by dx is equal to 1 upon 2. What is the derivative of log? It is 1. 1 upon 1 minus x. Derivative of log of 1 upon x will be 1 upon 1 minus x minus 1 upon 2. Log of 1 plus x derivative will be 1 plus x. So, which I get is 1 upon y dy by dx is equal to 1 upon, which is equal to 2, 1 minus x into 1 plus x, which is equal to 1 plus x minus 1 plus x. Okay. Take the LCM, cross multiply. What will cancel? Plus 1 and minus 1 will get cancelled. You will have 2x. Okay, yes. This is 1 upon 1 minus x, and derivative of minus x is minus 1. Derivative of minus x is minus 1. So this minus sign is very important here. So I have, okay, because normally what do I have? I have log x. Derivative of log x is 1 upon x. Then derivative of 1 upon 1 plus x is log x. Log of 1 plus x is 1 upon 1 plus x. But log of 1 minus x, this is equal to minus 1 upon 1 minus x. Why? Because there is this minus in front of this x. Okay, so this will become, cross multiplication will become minus 1 plus x minus of 1 minus x. So this is equal to minus 1 minus x minus 1 plus x. Okay. So what happens is minus x plus x will get cancelled, and I am left with this upon 2 1 minus x into 1 plus x. So this is equal to minus 2 upon 2 1 minus x into 1 plus x. Again this 2 will get cancelled. Okay. So I have 1 upon y dy by dx. So dy by dx is equal to, now this y is going to cross multiply, it's going to come here. So I have dy by dx is equal to y with a minus sign upon, what is this? This is 1 minus x into 1 plus x. This is equal to 1 minus x square. Okay. Now what is important is I just have to rearrange this. I have to rearrange. So are they asking me? They're asking me 1 minus y square dy by dx is equal to how much? Okay. So I take this 1 minus x square that side. So this is equal to 1 minus x square dy by dx is equal to minus y. So what do? They want it this side. So I take this minus y this side. So this becomes 1 minus x square dy by dx. This minus y, it comes this side, it becomes plus y. What is left on the RHS? Nothing. So it becomes equal to 0. Okay. So value of the function y was given. Okay, the function y was given, and then they asked you to find out what is 1 minus x square dy by dx plus y. In the book, it is written show that, but obviously you don't have writing answers. So it will be, they will just give you this and ask you whether its value is equal to 0, 1, 2, 3. Okay, so here what I have done, I've taken log y is equal to, I've taken log on both sides and simplified. Okay. Yes, Komalpreet, good afternoon. Yes, it is minus y, and then we take it onto this side, it becomes plus y. Okay. Now let me show you by squaring also. This is y is equal to 1 minus x upon 1 plus x. Y square root of 1 minus x upon 1 plus x. Squaring both sides, I have y square is equal to 1 minus x upon 1 plus x. Finding the derivative, this is 2y dy by dx. Now which formula will I use? This is d by dx of u upon v is equal to upon v square, v into u dash minus u into v dash. Okay. So we are going to use this. So this becomes is equal to upon 1 plus x the whole square, and v is 1 plus x. What is the derivative of 1 minus x? It is minus 1. Minus 1 minus x. What is the derivative of 1 plus x? It is equal to plus 1. Okay. So this is equal to 1. Minus 1 into 1 is minus 1 minus x minus 1 plus x. Okay. Here you just have to be careful with this minus 1. Okay. And what will be there in the denominator? It will be 1 plus x the whole square. Now what will happen here is plus 1 minus 1 will get cancelled. Plus x minus x will get cancelled. And what do I have here is minus 2, 1 plus x the whole square. Write it over here. So I have 2y dy by dx to be equal to minus 2 upon 1 plus x the whole square. Now I'll cancel the 2 on both the sides. Okay. So what do I have now is, I just want dy by dx. So dy by dx into this 1 plus x square. I will take it onto this side. And what will I have here? This is equal to 1 upon y. Okay. Minus 1 upon y. So how much is this? 1 plus x the whole square dy by dx, okay, is equal to minus 1 upon y. Okay. Now what happens here is you have to put the value and then you will have to rearrange to get the answer. It is not impossible, but it becomes long. So you can, what you should do is, this is the better method. Taking logs on both sides is the better method. So why I have showed you this is because you should not be afraid of using logs. You know, so many times I see students are afraid of using logs. They will put the first chapter in option. Don't do that. First chapter is the most important chapter. That is the building block for the whole paper 3. Okay, so what you should do is, this becomes easier. Now it's not that you can't solve this. You can, you can take the value of y, you can resubstitute and you will still get the answer. There is no problem. But using that, it becomes easier. Okay. Any other doubt you have? Which example, Dimple, you want? Okay. This is all that I wanted to take with you, so that you should be able to solve the parametric, you should be able to solve using logs. Okay. Now your confidence has grown. So that is why I take it on the last and last, so that all your confidence has grown and all your problems have already been solved. This all this formula also we have done for all both differentiation and integration. Okay. Shreya, the formula is there. Okay. What does the formula say? D by dx of log x is 1 upon x. Now, what is the coefficient of x here? The coefficient of x here is 1. Okay. And what is the power? It is raised to 1. Okay. So, that it is 1 upon x. Now, d by dx of log of 1 minus x. Okay, when I'm considering this is equal to 1 upon 1 minus x, no doubt. But instead of this, what is happening here? This is minus 1. So this has to come minus. Here it was 1. So I have taken as 1. And that is why I have shown you the other method also. If I have log of 1 minus x, I can put let 1 minus x be equal to t. Then taking derivative, this will be minus dx is equal to dt. Okay. So what will happen? Suppose this is equal to y. Okay. So I will have y to be equal to log of t. I will have, because I have substituted 1 minus x is equal to t. So what will be my dy by dx? It will be equal to dy by dt into dt by dx. Okay. From here, dt by dx is equal to how much? Dt by dx is equal to minus 1. Okay, this minus 1 is there. Now, how much is dy by dx? Dy by dt, y is equal to log t, it will be 1 upon t. Dt by dx is equal to minus 1. And resubstitute, I resubstitute value of t. What is t? T is 1 minus x. Okay, so this becomes minus 1 upon 1 minus x. So this is how the minus 1 came. Okay, that's why I have in the start of the session only I had shown you how to substitute and get. Otherwise, you can directly also do. Okay, because this is minus x. So this will become minus 1 in the numerator. Okay. Okay, Nabin, have you understood? Shreya, have you understood? Dimple, that sum is there in the book? If what Dimple has asked, if that is the question, let me. Okay, y is equal to log of x plus 2 root x plus a square. Okay, in this case also substitute this to be equal to t. Okay, and then try to find the value. Okay. Samina, I have already showed integration of log x, right? Log x is equal to log x into 1 dx, and then you use the UV rule. Okay, the integration by parts. And it is there in the video. Okay, you can rewatch the video. Yes. Tanmeet 8b question 42. So let me see. Integration. Okay, don't worry. Okay, don't worry about that. Any other doubt you have? Because this is a good chapter, scoring chapter, you can get it. Dimple, square root of x square, a square is for both of this. Can you tell me the page number, Dimple? Okay. Okay, it is log of x plus square root of x square plus a square. Okay. Okay, so in that, okay, sorry, I forgot to share the screen. She is asking this question, log of x plus square root of x square plus a square. That is again under the square root. Now here again, see what you can see is that what you have to do is, this is log of something. Okay, so derivative of this will be 1 upon x. I know that d by dx of log x is equal to 1 upon x. So derivative of this will be 1 upon this. Okay, this and this is the same. But it is not only x. This is again a function of x. It is not simply x. It is a function of x. So what I need to do is I need to find the derivative of this function. So I have to again find this derivation of this function. So this is again finding the derivative. You get 1 plus 2x upon 2 under root of x square plus a square. See, you can use this 1 upon x plus square root of x square plus a square. You can multiply this. You have to simplify the denominator. This is x minus under root of x square plus a square upon x minus under root of x square plus a square. So what will the denominator simplify? The denominator will simplify to x square minus x square plus a square. Okay, because this becomes a minus b into a plus b, and this will get cancelled. Okay, so this gets cancelled. Now this will be left with is x minus square root of x square minus a square. Okay, so and this is upon a square, so this will be equal to 1 upon a square x minus square root of x square minus a square, and then I solve this and I get the answer. Okay, so this is how you are supposed to do it. So this portion is nothing but d by dx of log x is 1 upon x. So in case of this is the whole function, this whole function I am repeating over here. Okay, this blue line I am repeating over here, and this function, oh sorry, okay, this function this function here I will be using. So this function, derivative of this function is this. Okay, derivative of this function x plus square root of x square minus plus a square will give you this, and then when you simplify this you will get the answer. Okay, you have to simplify, and once you simplify you will get this answer. Okay, yes, logarithm differentiation Vadekar we have already taken. Okay, again here the derivative of log function, this log function you have to first, the derivative of the log will be 1 upon the function e raised to x and this, and then you have to find the derivative inside the derivative. Okay, and just like we did just now, you have to solve it completely. Okay, so that's all for today. Okay, I hope you've understood all this. Yes. Yes, Rajesh, you've understood? Dimple, yes. Samina, okay? Yes, thank you, Samina. Thank you all for your patient hearing. Have a great day ahead. Thank you.